Download this code from codegive.com, link in the description below. Bypassing file upload restrictions and PHP parse errors using AI, a detailed tutorial. This tutorial delves into the challenging realm of bypassing file upload restrictions and exploiting PHP parse errors, leveraging the power of AI to generate payloads and identify vulnerabilities. It's crucial to understand that the information provided here is for educational purposes and should only be used in ethical hacking environments with explicit permission. Unauthorized attempts to bypass security measures on systems you do not own or have permission to test are illegal and unethical. Understanding the landscape *. Before diving into the technical aspects, let's establish a solid foundation. A file upload vulnerabilities *. File upload vulnerabilities arise when a web application allows users to upload files without proper validation and sanitization. This can lead to severe consequences, including remote code execution, RCE uploading and executing malicious code on the server. Cross-site scripting, XSS uploading files containing malicious JavaScript code that can be executed by other users. Denial of service, DOS uploading large files or exploiting vulnerabilities to overload the server. Information disclosure uploading files that can be accessed by unauthorized users, potentially revealing sensitive data. Common file upload restrictions Web applications often implement various restrictions to prevent malicious file uploads. These may include file extension filtering, blacklisting/whitelisting restricting the allowed or disallowed file extensions, example only allowing .jpg, .png, .pdf or blocking .php, .exe, .sh. Blacklisting is notoriously weak. MIME type validation checking the content type header sent by the client, attempting to verify the file type. This is easily bypassed as the client controls the header. File size limits restricting the maximum size of uploaded files. File content scanning analyzing the file content for malicious patterns or code. File name sanitization modifying the file name to remove potentially harmful characters or enforce a specific format. Upload directory permissions limiting the execution privileges in the upload directory to prevent code execution. HTTP 403 forbidden error The HTTP 403 forbidden error indicates that the server understands the request, but is refusing to fulfill it. In the context of file uploads, a 403 error can occur due to various reasons. Insufficient permissions the user account attempting the upload does not have the necessary permissions to write to the upload directory. Access control lists, ACLs are configured to deny access to specific users or IP addresses. Web server configuration the web server, example Apache, Inks, is configured to restrict access based on file type, URL, or other criteria. Commonly, .access files can block certain file types from being served by Apache. Web application firewall, WAF A WAF might detect malicious patterns in the upload request and block it. IP address blacklisting the client's IP address is blacklisted by the server. Rate limiting the client is attempting to upload files too frequently. PHP parse errors PHP parse errors occur when the PHP interpreter encounters syntax errors in the code. Exploiting parse errors during file uploads can be useful in several ways. Bypass content-based filtering by deliberately introducing errors, you might be able to circumvent content-based filtering mechanisms that attempt to analyze the file content for malicious code. The server may stop processing after the error, bypassing later security checks. Trigger error messages. Sometimes, the server's error handling configuration might inadvertently reveal sensitive information, example file paths, database credentials, in the error messages. This is generally only possible on badly configured servers in a testing environment. Information gathering. Analyzing the specific type and location of the parse error can provide insights into the server's PHP configuration and code structure. 2. AI-powered payload generation and vulnerability identification. AI, particularly large language models, LLMs, like GPT-3, GPT-4, or other models available through APIs or open source, can be immensely helpful in generating payloads. Crafting various payloads to bypass file extension restrictions, MIME type validation, and other security measures. Fuzzing. Creating a range of inputs to test the application's behavior and identify vulnerabilities. Bypassing WAFs. Generating payloads that are designed to evade detection by WAFs. Finding PHP parse error injection points. Identifying ways to inject code that triggers predictable parse errors for information gathering. Setting up the environment. Unethical hacking lab. Set up a local development environment or use a platform like Hack the Box or TryHackMe for safe testing. 2. Web application. Install a vulnerable web application that allows file uploads, example OWASP Juice Shop, DVWA, custom built app. 3. AI access. Gain access to an LLM either through an API, example OpenAI, Google AI platform, or by running a model locally, example using Hugging Face transformers. Be mindful of API usage costs. 4. Burp Suite or similar proxy. Use a web proxy to intercept and modify HTTP requests and responses. B. Bypassing file extension restrictions with AI. Let's assume the application only allows .jpg files. 1. Prompting the AI*. 2. Explanation of the prompts*. Example 1*. This prompt is the most powerful. It asks the AI to generate a valid JPG file containing PHP code that will execute when the file is included in a PHP script. This requires careful crafting of the PHP code to avoid corrupting the JPG structure. This relies on being able to include / require the file. Example 2*. The AI is prompted to suggest file names with double extensions, example image.jpg.php, which might be processed by the server in a way that interprets the second extension. Example 3*. The AI is prompted to provide a case-sensitive file name, example image.jpg. This relies on a misconfigured server that doesn't properly handle case sensitivity. Example 4*. The AI is prompted to create a file name using a null byte injection, image.jpg%00.php. Older systems might truncate the file name at the null byte, allowing the .php extension to be ignored during validation but processed by the web server. 3. Creating the exploitable file*. For example 1, take the payload_jpg output and save it to a file, example image.jpg. For examples 2 to 4, rename a standard image file, example image.jpg, to the generated file name. In example 4, the null byte is a special character that needs to be properly encoded in the file name, example using URL encoding %00 in the file name. 4. Uploading the file*. Use the web application's file upload form to upload the crafted file. 5. Testing the exploit, for example 1. After uploading the file, you'll need to trigger its execution. This usually involves knowing the upload directory and crafting a URL that includes or requires the uploaded file. For example, if the file is uploaded to /upload/image.jpg, you might try accessing http://example.com/upload/include.php, file equals image.jpg, where include.php contains the following code. Warning: the include function with user-supplied input is extremely dangerous and should never be used in production code. It's only used here for demonstration purposes in a controlled testing environment. If the server is vulnerable, the fpinfo function will execute, displaying the server's PHP configuration. C. Bypassing MIME type validation with AI ***. MIME type validation is often weak because the content type header is controlled by the client. 1. Prompting the AI ***. 2. Explanation of the prompt ***. The AI is asked to generate a list of MIME types that, while not typically associated with PHP, might be accepted by a misconfigured server and trigger PHP execution. 3. Modifying the HTTP request ***. Create a PHP file, example shell.php, containing the PHP code you want to execute. Use Burp Suite or a similar proxy to intercept the HTTP request when uploading the file. Modify the content type header in the request to one of the MIME types suggested by the AI, example image/JPEG, text/plain. Forward the modified request to the server. 4. Testing the exploit ***. After uploading, try to access the file through the web server. If the server is misconfigured, the PHP code might be executed. D. Bypassing 403 forbidden errors ***. Bypassing 403 errors is often more about understanding the server's configuration and trying different approaches. AI can help generate payloads for specific techniques. 1. Identifying the cause ***. Carefully analyze the 403 error response. Does it give any clues about the reason for the denial? Check server logs, if you have access, for more detailed information. 2. Potential bypass techniques, with AI assistance. Case sensitivity, AI as mentioned earlier, try variations of the file name in different cases. URL encoding, AI encodes special characters in the file name or URL. Path traversal, AI try to traverse up the directory structure using /sequences. Be extremely careful with path traversal, it can lead to unauthorized access to sensitive files. HTTP verb tampering * try using different HTTP verbs, example put, post, options, to upload the file. X forwarded for header ** if the server is blocking your IP address, try setting the X forwarded for header to a different IP address. This only works if the server trusts the X forwarded for header, which is generally a bad practice. 3. Testing the bypass ***. After generating potentially useful payloads or alternate file names, use Burp Suite to intercept the upload requests. Try the alternate file names, URL encodings, HTTP verbs, or even adding the X forwarded for header with an alternate IP address. Inspect the server's response for each attempt. Exploiting PHP parse errors with AI ***. 1. Prompting the AI ***. 2. Explanation of the prompts ***. Example 1 ***. The AI is asked to create a PHP payload that will generate a specific type of parse error and include a particular string in the error message. This is useful for triggering error messages that might reveal sensitive data. Example 2 ***. The AI is asked to craft a PHP payload that will predictably trigger a common parse error, Unexpected t_string. Analyzing the server's response to this specific error can provide insights into the code structure. 3. Uploading the file and analyzing the response asterisk. Create a PHP file, example error.php, containing the generated payload. Upload the file through the web application's file upload form. Access the file through the web server. Carefully analyze the server's response. Look for error messages. Are they revealing any sensitive information? File paths. Can you determine the location of the error? PHP configuration details. Are any PHP settings exposed? For example, payload, generated by AI. If the web server is configured to display errors, accessing this file should reveal a parse error with the unexpected t_variable, expecting, or, message, and potentially expose the line of code containing $secret_key. Note that this is bad server configuration and is unlikely in a production environment, but it's something to check for in testing. 3. Important considerations and best practices ethical hacking always obtain explicit permission before testing any security measures on systems you do not own or have authorization to test. Defense in-depth implement multiple layers of security to mitigate file upload vulnerabilities. Input validation thoroughly validate all user input, including file names, file extensions, MIME types, and file content. Sanitization sanitize file names and file content to remove potentially harmful characters or code. Content security policy, CSP implement CSP to restrict the execution of JavaScript code from untrusted sources. Regular security audits conduct regular security audits and penetration testing to identify and address vulnerabilities. Least privilege principle grant only the necessary permissions to users and processes. Secure configuration ensure that the web server and PHP are properly configured with security in mind. Disable allow_URL_include, allow_URL_fopen, restrict access to the upload directory. Keep software updated regularly update all software components to patch known vulnerabilities. Web application firewalls, WAFs use a WAF to detect and block malicious requests. However, remember that WAFs can be bypassed with carefully crafted payloads. AI limitations AI generated code should always be reviewed by a human expert. AI can make mistakes, and relying solely on AI generated payloads can lead to false positives or missed vulnerabilities. Furthermore, the AI might produce non-functional or unreliable code. Rate limiting implement rate limiting to prevent attackers from brute forcing file upload attempts. File size limits enforce appropriate file size limits to prevent denial of service attacks. Monitor upload directory implement monitoring to detect suspicious files or activities in the upload directory. 4. Code example, illustrative, simplified for clarity. This example demonstrates a basic, and insecure, file upload script and how it can be exploited with a double extension payload. Exploitation 1. Create a PHP file create a file named evil.php containing PHP code, example php-info. 2. Rename the file rename evil.php to evil.php.jpg. 3. Upload the file upload evil.php.jpg using the provided form. 4. Access the file if the server is configured to execute PHP files in the upload/directory, Accessing http://example.com/upload/evil.php.jpg will execute the PHP code. This is because the server might only check the last extension or, worse, not validate the name. V. Conclusion ****. Bypassing file upload restrictions and exploiting PHP parse errors requires a deep understanding of web application security principles, server configurations, and common vulnerabilities. AI can be a powerful tool for generating payloads, fuzzing, and identifying potential weaknesses. However, it's essential to use AI ethically and responsibly, and to always validate AI-generated code with human expertise. Remember that defense in depth is crucial, and multiple layers of security should be implemented to protect against file upload attacks. The examples given are simple and likely would be blocked by modern security systems. The power is in using AI to understand weaknesses and create custom attacks. Always prioritize ethical hacking practices and seek permission before testing security measures on any system.